Hi everyone, welcome to our webinar where we're going to present how Microsoft Defender for Cloud is a cloud-native application protection platform. We will be walking through different sorts of agenda items, starting with what are cloud-native application protection platforms, how is Microsoft Defender for Cloud a cloud-native application protection platform, and with that, we're going to be talking about our contextual CSPM, Cloud Security Posture Management capabilities, Cloud Workload Protection, Defender for DevOps, and Cloud Infrastructure Entitlement Management. So to get started, we're going to start off by defining what cloud-native technologies and applications actually are. Cloud-native applications are a modern approach to developing software. As the Cloud Native Computing Foundation defines, cloud native technologies are what allow organizations to build and run scalable applications in dynamic environments. By dynamic environments, I mean public, private, or hybrid cloud environments. The focus is how the applications are created and deployed, not where they're created and deployed. Cloud native applications are typically made up of different small interdependent services, which are called microservices. Each service is owned by a self-contained team and is built for a specific business capability, meaning that each service would perform a single function. The services communicate with each other via APIs, which is very different than the traditional monolithic applications where all the application processes are tightly coupled and ran as a single service. With monolithic applications, if one process of the application experienced a spike in demand, the entire application would need to be scaled out, and that can be very expensive and resource demanding. But with microservices, since each service is independently run, a service can be updated, deployed, and scaled on its own to meet the customer demands. Since everything is so separated, these applications support fast and frequent changes without impacting delivery, giving adopters of cloud-native technologies an innovative competitive advantage. The adopters are able to bring new ideas to market faster and respond to changing customer demands. Microservices, they're typically containerized, so the microservice code and other required files, they're packaged into a single compute unit, which makes it easy to have these cloud-native applications run independent of the underlying operating system and hardware, and it makes them more resource efficient and therefore more cost-effective. And the last thing I wanted to point out here is that cloud-native applications go hand in hand with DevOps. Microservices very much enable continuous integration and continuous delivery. Continuous delivery is the practice of moving software changes into production continuously through automation, which allows developers to decrease the software delivery timeline and respond quickly to changing user expectations by delivering those accurate features that correspond to those user expectations. They're able to be more innovative because it's easy to roll back, so the cost of failure is lower, and that therefore increases the speed of innovation. Now, moving on to how this new cloud-native architecture affected the typical usage of securing cloud environments through cloud security posture management. As enterprises, they shift their workloads to the cloud. Securing cloud environments has become very necessary, and with organizations adopting cloud-native technologies, they're starting to realize that the unique characteristics of cloud-native applications makes them impossible to secure without a complex set of overlapping tools that span development and production, including infrastructure as code scanning and container image scanning, to ensure vulnerabilities and misconfigurations are remediated before they're actually deployed to production. We need cloud workload protection platform capabilities to provide comprehensive and targeted threat protection for running workloads, whether those are on premises or in the cloud. We do still need cloud security posture management to assess configurations of the cloud platform's control plane, the infrastructure. Another really important aspect is cloud infrastructure entitlement management, which will monitor permissions and user activities of both the users in the organization and service accounts to make sure that they're operating within appropriate access controls. So with all of these different spanning capabilities, we can understand that just having cloud security posture management isn't enough. You need to understand and address the real risk of cloud applications by bringing together different analytics with context. So understanding why a certain component is vulnerable, the true risk of an application, it requires this correlation of this historically siloed set of information, because even if there is a vulnerable component in an application, like I just mentioned, if the application isn't used in production, it's an internal application, it doesn't have any sort of external exposure, it's not going to be as high of a risk as a vulnerable component in an application that is externally accessible. So customers need this context, and they need the ability to explore and query for specific vulnerabilities to find the risk that matters most to them. They also need to be shifting left to remediate the vulnerabilities before they ever make their way to production in the first place. One example, if you think of containers, you need to patch the vulnerabilities as early as possible because they're immutable. You can't patch a running container in a Kubernetes cluster. So you need to be able to really go down the development pipeline, catch the vulnerabilities as early as possible, and remediate those before they go into runtime. And that's where cloud-native application protection platforms come into the picture. Cloud-native application protection platforms bring together different sets of cloud security tools, including cloud workload protection and cloud security posture management. Some vendors bring in other tools as well, such as cloud infrastructure entitlement management and tools to manage container and infrastructure as code scanning prior to deployment, like I mentioned earlier. The cloud-native application protection platforms will scan workloads and configurations in development and protect them during runtime. The most significant benefit we have here is better visibility and control of cloud-native application risk in a single tool set that brings together all different sorts of context, from open source software vulnerability scanning, code scanning, container image scanning, cloud infrastructure posture management, and runtime protection. So now I'm going to hand it off to Future to discuss how Microsoft Defender for Cloud is a cloud-native application protection platform.
All right, thank you so much, Lara, for that introduction. So Lara went over some of the key things that come to mind when we think of cloud-native application protection solutions. And in this diagram here, we're really encapsulating how Defender for Cloud is an end-to-end solution that allows customers to leverage these various cloud-native application protection capabilities. So from development lifecycle through production, Defender for Cloud provides different capabilities to help secure your resources, whether they're in Azure, AWS, GCP, or on-premises. And if we take a closer look at exactly what this means, we've laid out the different capabilities here that really make Defender for Cloud a cloud-native application protection solution. So when we look at cloud security posture management, we do have 3 foundational cloud security posture management capabilities, which we'll take a look at later, as well as the Defender CSPM plan that we recently released, that includes integrations with intra-permissions management and Defender EASM, as well as the Microsoft Cloud Security Benchmark. And then we also have DevSecOps capabilities from our new Defender for DevOps plans that allow you to unify, strengthen, and manage your Defender and manage your DevOps security across multiple pipelines. And then finally, when we look at cloud workload protection, we do have these different plans: Defender for servers, containers, SQL, OSS databases, Cosmos databases, Resource Manager, DNS, and Key Vault, as well as the Defender for containers and Defender for servers plan. So we have done different webinars in the past that go into way more detail than we have time for these different plans. So I would encourage you to look at our library of webinars to get a more comprehensive overview of each of the different Defender plans. So first, we'll start off with the Cloud Security Posture Management. So Cloud Security Posture Management, as Lara explained before, is looking at providing you hardening guidance and making sure that your resources are configured security. So with Cloud Security Posture Management, you can remediate security issues within your environment and then watch your security posture improve. And when we take a look at the Cloud Security Posture Management capabilities for Defender for Cloud, you'll notice that we have these two tier of capabilities, the first being the foundational CSPM capabilities, and then the recent capabilities that we introduced as part of Defender CSPM. When we look at foundational CSPM capabilities, this includes things like asset inventory and the secure score, which is a measurement of how secure your resources are, as well as advanced remediation capabilities, such as being able to apply a quick fix logic and using logic apps to remediate your different resources. And then we also integrate with Azure workbooks and allow you to integrate with a SIEM of your choice, such as Microsoft Sentinel. And finally, you can trigger different custom workflow remediations for your resources. And then when we look at the Defender CSPM, we introduced the Agentless vulnerability scanning capability, as well as integrated with the Defender EASM and intra-permissions management, which we saw in this slide, and Defender for DevOps, which Lara will go over later in this presentation. And then we also added contextual capabilities, such as the cloud security map and the attack path analysis. And then with CSPM, you're also getting access to the regulatory compliance dashboard and being able to apply industry benchmarks to your workloads. And recently, we've added the governance at scale capability as well for you to be able to run different campaigns, run different remediation campaigns for those workloads. So let's take a closer look into some of these things that I just mentioned and see how they work within Defender for Cloud. So first off, when you onboard to Defender for Cloud, you get this centralized view of your cloud security posture management capabilities. And you'll see here, you can see that security posture within the window, as well as the inventory. And when you onboard, you're able to see the security posture of your resources across all three key clouds. So not just Azure, but AWS and GCP. And you're also able to see that inventory of every single resource that you've onboarded to Defender for Cloud. In addition to that, you also get the secure score, and you'll see this score here, which is a measurement of how secure you are across these different cloud environments. And this secure score is built upon over 450 out-of-the-box recommendations that we have within Defender for Cloud. And these recommendations are a result of the Microsoft Security Benchmark. So with these recommendations, we also provide you steps for how to remediate the recommendation. And some of them even come with a quick fix, which allow you to remediate within a single click or apply at-scale remediation. So with the quick fix, we run a remediation logic, which you can view beforehand, and that is applied to the unhealthy resources that you select. And then in addition to this, you can also integrate with logic apps to provide additional at-scale remediation for your recommendations. So these are the foundational CSPM capabilities that we have within Defender for Cloud. And then when we take a look at the capabilities for the Defender CSPM plan, This is where we introduce the agentless scanning, the attack path analysis, and cloud security graph, as well as integrating with the compliance and governance tools. So with Defender CSPM, we're really adding on to those foundational CSPM capabilities and allowing you to do more with less. So for example, we've introduced that agentless scanning, which is enabling full visibility and coverage of your virtual machines across your cloud environments. So you no longer need to deploy an agent for security posture capabilities, but you'll still need them for workload protection capabilities that we'll take a look at later. And then with attack path analysis and the cloud security graph, this is where you can identify the most critical security issues and reduce the recommendation noise. So instead of looking at all the recommendations in your environment, you can focus on the ones that are most important based on exploitability and risk. And then finally, with the integrated compliance and governance tools, this is where you can create different remediation campaigns and assign an owner and an ETA for those campaigns, as well as make sure that your resources are secure across different industry benchmarks. When we take a look at agentless scanning, we realize that when it comes to maintaining your cloud security posture management with agents, there are several challenges that you may face. So one could be that the machines are ephemeral or they're short-lived. So they're only up, for example, 8 hours at a time, which may not be long enough for you to deploy an agent. We also recognize that there can be installation failure. So some issues may come up with deploying the agent, and then you'll become dependent on different workload owners and different groups to help you troubleshoot those issues. And then also some of these machines may have limited connectivity as well, which could prevent you from deploying the agent or introduce additional challenges. So with this in mind, we've introduced the agentless scanning capability for the Defender CSPM. So with agentless scanning for your virtual machines, you get a wide visibility into the installed software, but also the vulnerabilities that we've discovered without relying on an agent, which also means that there's little to no performance impact on your workloads. So with the agentless scanning, what we're doing here on the back end is that we're taking a snapshot of the virtual machine disk, and then we're doing an out-of-band analysis of the OS configuration and the file system that's stored within the snapshot. And then from there, after we get the necessary data from this disk, Defender for Cloud will immediately delete the copied snapshot of the disk and then send that metadata back to the Defender for Cloud backend for analysis. And this analysis is being done by the Defender Vulnerability Management Scanner. And you'll notice here in this snapshot that I have for EC2 instances should have vulnerability findings resolved. This experience is actually the same as what some of you may have seen in the past with the agent-based scanner. So the end results are really the same here, where you're able to see the different security findings and the affected virtual machines from our vulnerability assessment results. And with this agentless scanning, so this is available for the Azure virtual machines as well as the AWS machines. Another capability that we'll look at as part of the Defender CSPM includes the Cloud Security Graph. So the Cloud Security Graph is actually a context-based engine within the Defender for Cloud backend. So what it's doing is it's actually collecting data about your multi-cloud environment from numerous data sources. So this includes the cloud asset inventory, the different connections between your resources, as well as things like exposure to the internet, permissions, and a lot more. So with all this information, it models this data as a graph of these interconnected assets on the back end. And then from there, we're able to bring you these two new capabilities. The first one is the Cloud Security Explorer. The first one is the Cloud Security Explorer. And with this Cloud Security Explorer, we're allowing you to query that cloud security map and build your own custom queries as well. So with this, the security team can use a query builder, which is this interactive tool that will allow you to locate different risks while taking your organization's specific context into mind, and allow you to do more proactive exploration of these security risks. And one example of this is the Open SSL v3 vulnerability, which we've published some blogs on. And with the Cloud Security Explorer, we were actually able to use this interactive query to show you what machines or Kubernetes images were impacted by the SSL v3 vulnerability. And I'll show you this example once we get to the demo. But you'll see here we were able to use that interactive query to narrow down the virtual machines and then look at these specific CVEs for the vulnerability. And then the second thing that we were able to introduce as part of the cloud security map is the attack path analysis. And the attack path analysis is a graph-based algorithm that scans the cloud security graph, and it's able to do two things from that. So first off, it's able to expose any exploitable paths that the attacker may use to breach your environment and breach your high impact assets. And then the second thing, it's able to provide you recommendations from those different attack paths to prevent any successful breaches. And we actually have a list in our documentation of all the possible attack paths that are available with this capability, which I'll ask one of my colleagues to post within the Q&A. But as you can see in the screenshot here, we're looking at internet exposed VMs with high severity vulnerabilities and read permissions to a key vault. So it's actually showing you step by step how an attacker could use these different resources to eventually gain access to this key vault here. And it's showing you different information such as how these resources are routing traffic or how they have permissions to other resources within your environment. So in addition to what I've mentioned before, as part of Defender CSPM, we've also have governance at scale and auto remediation. So with the governance at scale, you're able to answer different questions such as who should be resolving a recommendation, when can you expect these recommendations to be involved, and from there, you're able to create campaigns by creating these different governance rules, which will assign an owner to a different set of recommendations. And with that, you can assign a due date as well that will say when the recommendation is due. So this is really helping you to improve the remediation process when it comes to cloud security posture management. And then you can also integrate with ServiceNow via Azure Logic Apps as well. And one of the things that I mentioned before, which is part of the foundational capabilities, is being able to use workflow automation to also remediate the different recommendations as well. And then finally, for Defender CSPM, this also includes compliant assets and management. So aside from looking at the out-of-the-box recommendations, you can assign different industry standards such as PCI, NIST, SOC, ISO, HIPAA, etc., and see how your resources are compliant with these different industry standards. And you're able to manage that through this regulatory compliance dashboard here in the portal. And we've also added this new feature that will actually show you what compliance offerings are available for the different resource types. So now that we've got a little background here on the CSPM capabilities, the cloud security posture management capabilities that are available, I'd like to show you what some of these look like in the portal. Oops. So when we go here to the Defender for Cloud portal, so first off, you'll notice when you go to the overview page, you have this overview here of your cloud security posture management and also a sneak peek at the workload protection. But you'll see at a glance the security posture and the secure score across the three different clouds that you have onboarded. as well as the recommendations that have been unassigned that are overdue in the attack paths as well. You also get a sneak peek at the regulatory compliance and the different compliance standards that have been onboarded. And finally, that inventory that shows you all the resources that are being monitored in Defender for Cloud. So when we first take a look here at the inventory, you do have these different filtering capabilities that allow you to narrow down your view to see the resources that you have onboarded. But if we take a look at this virtual machine, for example, one of the cool things about the inventory is that you can see all the related recommendations and the alerts from this specific resource that you've clicked. So in this case, with my virtual machine, I can actually see all the recommendations that are applicable to this virtual machine. And it tells me at a glance if it's healthy or unhealthy. And then from there, I can see all the applicable alerts as well. And then as part of the Defender vulnerability management, I can also view the installed applications on that virtual machine. And another thing that we have with Cloud Security Posture Management is this security posture view, which again, you can see that secure score, and you can see the environments, the different environments that have been onboarded. And you do have these 3 different filters here that allow you to focus on one or more of these environments at a time. But if you scroll down, you can see your environments at a glance and also the secure score and the unhealthy resources and number of attack paths. If we take a closer look at one of these and click view the recommendations, you can see all the applicable recommendations for that environment. So right now I'm viewing an Azure subscription, which is what it's showing here. And I see all the recommendations that are needed for this Azure subscription. I also see the secure score as well. And then, so if you were to click on one of these recommendations here, when you click on the recommendation, you'll get steps on how to remediate the recommendation. So if we take a look at remediate security configurations, you'll see all the applicable recommendations for that security control. And then you'll see different information such as the severity of the recommendation, the freshness interval, which is how often the recommendation is refreshed, the description that explains what it's looking at, as well as the remediation steps that you'll need to take. So everything that I've mentioned so far is part of the foundational CSPM capabilities. So these are free and they're generally available. Now we'll take a closer look at the Defender CSPM. So Defender CSPM is a plan that you will have to turn on, and you can see I've already turned this on within the portal. And once you turn on, you can actually go to the settings and monitoring. And for the settings and monitoring, you can make sure here that you also have the Agentless Scanning turned on as well. So this is really a look at how you would turn on Defender CSPM. And then when so to get there, I went to the environment settings and then I clicked on my subscription. But one thing you also notice on this environment settings is the access to the governance rules. And I've already gone ahead and opened them here to the side. What I mentioned before is that these governance rules are allowing you to run different campaigns and assign owners and remediation to better remediate the workloads that you have. So we're just looking at an example of a governance rule that's already been created here called Management Cosmos. And you'll notice the priority, which is the order that these different rules are completed. And you'll also notice the scope, and we've introduced at-scale governance rules, which allow you to apply them not to just the subscription, but also the management groups as well. And if we take a look at the conditions here, you'll notice that you can either create a rule by severity, or you can select specific recommendations. And then you can also assign an owner, the time frame, how long you want this, how long you expect this to be completed, and then set different notifications. So notify the owner about their open and overdue task, or even notify the manager as well. And then with Defender CSPM, you'll also see the regulatory compliance. And this is where I mentioned being able to apply the industry standards to see how secure your resources are. So you'll see the Microsoft Cloud Security Benchmark, and then you'll also see these additional standards that can be added as well, such as ISO, PCI. And when you take a closer look at some of them, you'll be able to see the different assessments or compliance controls that are being monitored, and what exactly you'll need to do to make sure that you're following these best practices for PCI. And then the last two things I want to cover are the attack path and the Cloud Security Explorer. So with the attack paths, when you go to recommendations and then attack paths, you can see all the relevant attack paths in your environment. And this is taking a look at the possible paths an attacker could take to gain access into your environment. So if we look at this example, we'll see that within my subscriptions, I have virtual machines that are exposed to the internet, and they have high severity vulnerabilities. And you'll see there's 5 different paths that an attacker could use with this attack path. And you'll notice that it starts out with the entry and the target point, and shows you exactly how an attacker could leverage this path by showing you how all these resources are connected, and how they can eventually gain access to this virtual machine. And right next to that, you'll see the relevant recommendations for this attack path that you can remediate to be proactive and help prevent this attack. And then finally, with the Cloud Security Explorer, this is allowing you to query that cloud security graph that's being used as the context engine on the back end. And one of the examples that we looked at was being able to search for OpenSSL v3 vulnerabilities. So if we take a look at this example query here, this is an interactive query. So we started out by selecting the virtual machines, and then we one of the things that we filtered for on those virtual machines were the different vulnerabilities. And then from there, we were able to search for different CVE IDs. And here we've gone ahead, and you'll see these different templates that we have out of the box to help you get started. But we've gone ahead and input those relevant CVE IDs. And then from there, once you perform the search, you're able to see the virtual machines that are impacted by OpenSSL v3. So at a glance, that's a look at the cloud security posture management capabilities that Defender for Cloud offers. And when we go back here to our discussion on CNAPP, the next thing that we'll be looking at is the Cloud Workload Protection Platform. So this is looking at being able to identify any unique workload security requirements and help protect your workloads against threats. And when we think about how Defender for Cloud monitors cloud workload protection, we actually have a full stack coverage with dedicated detections across these different resource types here. So here we've laid out the specific resource types that are being covered with Defender for Cloud and the different plans that I mentioned before. So you can see it by compute, service layer, databases and storage, AWS, GCP, and on-premise workloads as well. So with these cloud workload protection capabilities, they're not just specific to Azure, but also specific to AWS, GCP, and any on-premises workloads you may have onboarded. And at a high level here, when we look at the cloud workload protection capabilities, this is really looking at the different capabilities that we're offering here. So the main thing that we have is the alert correlation. So when you turn on these different plans, you'll start getting alerts when Defender for Cloud detects any malicious or unusual behaviors across the resource types, which are then presented for you in the security alerts portal. And one thing that's important to mention with these alerts is that we do map them to the MITRE attack framework mapping, and show you what stage within the MITRE attack chain that the alert lies. And with that, we're also using leading threat intelligence for these alerts. So in order to discover and detect these alerts, we're relying on different Microsoft security specialists, which work in different fields like forensics and web attack detections, and also Microsoft security research. And our researchers are leveraging a wide array of different telemetry and global presence to be able to identify these malicious behaviors. And you'll also notice, as I mentioned before, that these capabilities extend across multi-cloud. And some of these alerts and threat detections are agentless, so you don't need an agent to be able to discover them. And in addition to that, we have agent-based alerts as well. And then finally, with the cloud workload protection part of Defender for Cloud, we also offer vulnerability management for some of your different workloads, such as containers, virtual machines, SQL machines as well. And when we take a closer look at the security alerts, this is how it's presented in the portal. I have an example here. So you'll see the name of the security alerts as well as the alert description. You'll see the severity, the status, and the affected resources as well. And as I mentioned before, you can see exactly where within the MITRE attack chain that this alert lies. And then finally, you see some alert details as well that are relevant to this alert. And you'll also have this Take Action tab that allows you to see exactly what you can do to prevent alerts like this in the future. From there, you can also, if you find that this alert is not applicable to your environment, we do have the capability to create different suppression rules as well. And in addition to that, you can integrate with the SIEM of your choice, like Microsoft Sentinel, to do further investigation of these alerts. And with that, I'm going to hand it back over to my good friend, Lara, to talk more about the Defender for DevOps offering.
Thanks, Future. Defender for DevOps is a new offering within Defender for Cloud that bridges the gap between development and security teams. With the rise of DevOps, there was a need to shift security left, but even still, security teams still had little to no visibility over security controls that were implemented within the DevOps space. Defender for DevOps removes this gap by providing visibility and centralized controls to security teams for a centralized view of the organization's security state. The new capabilities of DevOps, like I mentioned, they allowed the security teams to gain DevOps insights across multi-pipeline environments, including GitHub Enterprise and Azure DevOps, within a single console, Microsoft Defender for Cloud. Some of the key capabilities include unified visibility into the DevOps security posture, giving those security admins full insight and visibility into DevOps inventory, the different repositories that exist, the security posture of the pre-production application code and resource configurations across their different pipelines and cloud environments in the single view. It also includes the ability to strengthen cloud resource configurations throughout the entire development lifecycle. So securing infrastructure as code templates and container images to minimize the number of misconfigurations from actually reaching production environments. And then lastly, it has automated capabilities with integrated security intelligence to help security teams prioritize remediation of critical issues in code. Through comprehensive code-to-cloud insights within Defender for Cloud, security admins can now help their developers prioritize code fixes with actionable remediation and assign developer ownership by triggering custom workflows that go directly into the tools that developers are most familiar with. I am going to show you what this looks like in the portal. So within Microsoft Defender for Cloud, we now have a new page called DevOps Security. On this DevOps Security page, there's a ton of information that security teams can now use. So first, on the right side of the page, you can see your DevOps coverage, how many GitHub and Azure DevOps organizations you've connected over to Defender for Cloud, and how many repositories are included in those organizations that are now being protected. Moving to the middle, you can see the number of code scanning vulnerabilities, the number of exposed secrets, open source vulnerabilities, and outstanding recommendations overall for your DevOps security posture. And then on the very left, we have a key performance indicator of the number of vulnerabilities across all your DevOps connectors. So security teams get this visibility directly from Microsoft Defender for Cloud. If they wanted to drill down to a specific repository, they have the ability to now do that. So I can click on this Contoso Hotels Azure DevOps repository, and I can understand the resource health. Here I'm able to see that my code repository has secret scanning findings. So we've discovered secrets within this repository. The status is unhealthy, which means they're still currently there. So I'm going to open this up now, and I am brought into the recommendation. I have remediation steps to resolve the discovered secret. I am able to see the secret that was discovered. Here, there's an Azure Storage Account Access Key. I can open up the blade here to get some more information about the file that this secret was found in. I can even go into the build URL or the repo URL directly from here. I can choose to have a logic app be automatically triggered, maybe to open a work item in Azure DevOps to alert the developer, because as a security professional, I have the information I need about my DevOps repository and the health there, but I want an easy way to communicate with my developers. So that can be done through triggering a logic app, and it can also be done through configuring pull request annotations on this repository. So if I select this repository back in the DevOps Security Blade and press configure, this gives me the ability to turn pull request annotations on or off. For the developer, when this is enabled, when they look at their pull request, they'll be able to see a comment from Microsoft Defender for DevOps letting them know that we discovered a secret. Here it's an Amazon S3 client secret access key, and they are able to get remediation steps to remove or rotate the credential, use an approved key store to secure that better. We also have the ability to fail the pipeline. So here I have a pipeline that was failed because secrets were discovered. So we could see that the credential scanner discovered a secret, and this detected one or more breaking results. So the build then failed, and this secret never ended up making its way to production and completing the build. Another way for security teams to view their DevOps findings is through recommendations in Defender for Cloud. So this is what security teams, they tend to be most familiar with when they're using Microsoft Defender for Cloud. And here on the recommendations, we can look at the different security controls. The one where the DevOps posture findings are within remediate vulnerabilities. Here I can look through, see all the vulnerabilities on runtime resources, and then I start to get into my code repositories. The one I wanted to point out here was that code repositories should have infrastructure as code scanning findings resolved, because securing infrastructure as code is a key pillar of Defender for DevOps. Infrastructure as code, it automates the provisioning of infrastructure, which allows organizations to develop, deploy, and scale cloud applications with greater speed and reduced cost. And one infrastructure as code template may be used to create hundreds or even thousands of different workloads within production. So the same template would be used so many different times, And one security mistake would be replicated across every single deployment, which would cause runtime issues. So you want to be able to fix the issue at the source and make sure that infrastructure as code template is secured before it's deployed to hundreds or thousands of different workloads. So here in the infrastructure as code findings, I can see different security checks that were ran. I can see that in one template, my storage account isn't using the minimum, it's using minimum TLS version, and we may want to resolve that. I, as the security professional, and am able to see the file again. I can see that this was found in a bicep template. It's detected in line 34 of the code. So if I wanted to open this up, I would click on the HTML URL link, and this would bring up the finding that we have within the GitHub repository. And we recommend here that you should consider configuring the minimum supported TLS version to be 1.2. You can also enforce this setting through Azure policy. So both the developer and potentially the security team would be able to see the actual code where this misconfiguration came from, and they're able to really centralize those findings so security teams can help their developers remediate these issues as quickly as possible. And then lastly, what I want to show for Defender for DevOps is around the Cloud Security Explorer. I know that Future already showed this Cloud Security Explorer and how you can query the Cloud Security Graph using this, but this also applies to repositories as well. If we remember the Log4j vulnerability, it was really stressful for security teams to know exactly where they were exposed to Log4j, but now using the Cloud Security Explorer, they can easily query for it. So here I'm going to search for my GitHub repositories, and I am going to add a dropdown to say, show me my GitHub repositories that have a vulnerability where the CVE ID is equal to CVE 2022-23302, which is a Log4j vulnerability. I can press search here to easily identify my GitHub repository that contains this Log4j vulnerability. I can go to the repository from here. I can see remediation guidance for that vulnerability, the score of it, the severity, and open up more details to go into the recommendation and get the insight about the security finding of the vulnerability and any guidance that we have on remediating the vulnerability from the National Vulnerability Database. Back to the presentation now. By integrating repository posture management into Defender for Cloud, security teams now get a quicker path to detect different sorts of posture findings within their DevOps repositories. They can detect secrets, they can patch vulnerabilities or understand where vulnerabilities need to be patched, and resolve infrastructure as code misconfigurations. By giving this visibility in Defender for Cloud, where we have all different sorts of information about the health of runtime cloud resources, we provide true code to cloud contextualization. And then we also have the ability for security teams to assign developer ownership to fix any sort of issues and vulnerabilities that have the highest priority due to different contexts we can rely on from the Cloud Security Graph. Really, Defender for DevOps empowers security teams to shift left and help developers resolve critical issues. And then lastly, to wrap up the presentation, we will discuss how we can use Microsoft Entra Permissions Management within Microsoft Defender for Cloud. Microsoft Entra Permissions Management is a comprehensive cloud infrastructure entitlement management product that provides visibility and control over permissions for any identity and any resource across multi-cloud environments, meaning Azure, Amazon Web Services, and Google Cloud Platform. With permissions management, customers get a streamlined view into every action performed by every identity on every single resource, so they can have a look at where permission risk lies within the cloud infrastructure. Within Microsoft Defender for Cloud, we are able to bring in different recommendations that come from Entra Permissions Management. So one discovery that Microsoft Entra Permissions Management makes is the permission creep index. This is a metric that evaluates the gap between permissions used and permissions that are actually granted. So if you have a user that has owner permissions to a subscription, but they're only using contributor permissions, that will affect the permissions creep index because that is an over permissive permission assignment. The higher the number of unused high-risk permissions that you have, the higher your permission creep index score will be. Microsoft Defender for Cloud will give you a recommendation coming from Entra Permissions Management if you do have any sort of over-provisioned identities within your Azure subscriptions, your GCP projects, or your AWS accounts. So we're extending Defender for Cloud's protection with cloud infrastructure entitlement management capabilities now. To summarize, Defender for Cloud is Microsoft's unified cloud-native application protection platform that strengthens your security posture against evolving threats, accelerates threat protection, and provides the tools that you need to reduce risk throughout the entire cloud application lifecycle. And now we have about 3 minutes for Q&A. I know in the chat, we had a question about what type of agents and continuous logging export is required for cloud security posture management to work across different services in Azure. And I wanted to make sure that we all know that there are no agents or logging needed within Azure for cloud security posture management. The same goes for Google Cloud Platform and Amazon Web Services. Cloud security posture management is entirely agentless. Let's take a look at any other questions that we may want to cover. If you have any, please feel free to write it now. So there was a question about how is attack path different in Defender Cloud Security Posture Management, Defender External Attack Surface Management, and Threat Intelligence. And Yuri, one of the moderators, wrote that attack path is part of Defender Cloud Security Posture Management. We use External Attack Surface Management to validate internet exposure, but they are completely separate products. Defender External Attack Surface Management and Defender Threat Intelligence are not part of Microsoft Defender for Cloud. Entra Permissions Management has, this is another question in the chat, how to enable the Entra Permissions Management and how is it tied to Cloud Workload Protection. Right now it's integrated with Cloud Security Posture Management. And to enable it, you can go to the Entra Permissions Management portal or an Azure Active Directory within the admin portal over there. You can actually configure it and set it up.
Yeah, just to add on top of that, so our last webinar for this year will be Defender for Cloud and Microsoft Entra. So tune in on Thursday, December 15th to hear more about how the two work together.
Thank you everyone for your time.
Yep. Thank you so much, everyone. Have a nice evening and holidays.
Thank you to Lara and Future for being our guest today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. Once again, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/securitycommunity. You can also find the presentation from today at aka.ms/securitycommunity. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We'd love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/security webinar feedback. Thank you and see you next time. Goodbye.